This is day 1 of Unit 6 for AP Calculus AB. This is the warm-up we did for this day. It says find the antiderivative of 6x squared minus 2x plus 3, and then if x equals 2 and y equals 11, what does c equal? So we're going to start by taking the antiderivative. Antiderivative is 6x squared. We add 1 to the exponent, that makes it x cubed, and then divide by 3. So I'll just write it this way, 6x cubed divided by 3. We'll come back and simplify in a minute. Add 1 to the exponent, divide by that number, and the 3 becomes 3x, and of course, never forget that plus c. Okay, so when we simplify this, we get 2x cubed minus x squared plus 3x plus c. And that's what y would equal. If you think about it, what we were really looking at back in the original was a derivative. When we took the antiderivative, it took us back to the original equation. So that's why I put a y in front. So now if we look at the information, it says if x equals 2 and y equals 11, what does c equal? Very straightforward. Just plug in 11 for y, 2 for the x's, and then solve for c. I'd encourage you to pause the video and try that on your own. And once you solve all that out, I'm not going to do all that computation here, you should get that c equals -7. Now that is what I asked in this equation. What we're working towards, though, is what's called a particular solution. When you just take the antiderivative and leave it just like it was, like I'm highlighting right here, that's called the general solution to the antiderivative. What we're working toward is the particular solution. All that means is you have a value for c. So the particular solution for this would be 2x cubed minus x squared plus 3x minus 7. So I plugged in -7 for the c. This would be my particular solution. I suppose actually this would be my particular or general solution up here, since it's the simplified version. But again, the only difference between the general solution and the particular solution is that the general solution still has plus c, and the particular solution you've solved for c and plugged it back in. So let's look at a second example. It says find the antiderivative of 1 over 2 squared of x minus 4. If x equals 9 and y equals 43, what does c equal? Same process. I'm going to start by rewriting that before I take the antiderivative. Square root of x is the same as x to the 1/2. And then I'm going to bring that x to the 1/2 up top and make it 1/2 x to the -1/2. And then take the antiderivative. So I will add 1 to the exponent, that makes it a positive 1/2, and then divide by 1/2. And then the -4 becomes -4x, and of course I put plus c. So my general solution, since these 1/2s cancel out, is x to the 1/2 minus 4x plus c. And I can set that equal to y, because it's our original equation, so let's go ahead and do that. And get y equals, and that's our general solution. To get our particular solution, we're going to use the information they gave us about x and y to solve for c. If I plug in 43 for y and 9 for x, I can solve for c. Again, I'd encourage you to pause the video and try this on your own. Once you work all that out, you should get c is equal to 76. So the particular solution would be y equals x to the 1/2 minus 4x plus 76. And that would be our particular solution.